In this video, we're going to look at Pythagoras Theorem. Okay, it's to do with right-angled triangles. You can see I've already drawn a right-angled triangle and given us some dimensions. Those dimensions don't have units. Okay, it's just numbers that we can use to identify what this Pythagoras Theorem actually means. Okay, now we could go into the proof of why it works and everything like that, but just for now, I want us to see how it actually works, not so much why it works and how Pythagoras got this theorem. So first of all, I'm going to tell you that we're going to use A, B, and C in our formula. Okay, this is the key formula that we need to remember. This is going to help us use Pythagoras Theorem to solve problems with our right-angled triangles. Okay, so A squared plus B squared equals C squared. Now, what's that got to do with our right-angled triangle? Okay, I'm going to use the red that I used for A. Okay, to just make this side length 3 into a square here. Okay, now, when we look at A squared, anything with squared, we could always think about squared means it will be a perfect square, because if it's something squared, it's something times by itself. So think about when we're talking about area of a square. Okay, if it's 3 times 3, 3 squared, okay, it must make a square if all the sides are going to be 3, mustn't it? Okay, so the area of this one equals 9. Okay, now think about, we're going to use the 4 as B, so we'll use the black pen for this one. So this is a square of all sides of length 4. Okay, now, same principle as our A, the one with side length of 3. Okay, if it makes a square, if it's something squared, all the sides must be that same length. So the area of this one is going to be 16 units. Okay, 16, as I said, we don't have an actual measurement, it's just 16. Okay, our last side then, we've got this side here, which I've labelled as 5. So if we make this one into a square, okay, using our orange pen this time. Okay, we should know that if it is a square, so C squared, all the sides will be the same length. So this side here is going to be 5 as well, as are these two sides. So the area of this square is going to be 25. Okay, so what we've done there, we could also label these as A squared, okay, B squared, and C squared. So we said that the side with length 3 was A, the side with length 4 was B, the side with length 5 was C. Okay, so let's see, we've got A, B, and C here, A squared, B squared, and C squared. We've also got it here, here, and here. Does that make sense within our equation then? So we said A squared plus B squared equals C squared. So A squared was 9. Okay, A squared equals 9. B squared was 16. Okay, now if we think, what is 9 plus 16? We should know fairly quickly that that would be 25. Okay, let's have a look at our C, our square for C. So C squared was, in fact, 25. So it does work. Okay, so it's interesting that that's the way it works. Hopefully that helps us to visualize what we're trying to do here. So where we see that sign for square, the small 2, okay, we're actually thinking about making that a square. So that's the same length on each side. What's the area going to be, essentially? Okay, so let's put that into a bit of practice. Okay, it's all good knowing that, but we need to know how to apply it as well. Okay, so example 1. Here's our right-angled triangle. Remember I said it only works for right-angled triangles. Okay, this time we're going to use this side as 6, this side as 8. And I'm going to call this one x. I want us to find out what x would be worth. Okay, so again, remembering this, A, B, and C. Now just be careful. The only thing we need to remember here is that C is always going to be the longest side. Okay, it's what we call the hypotenuse. So C, let's use our orange pen just to make it clear. So C is always the longest side. We call it the hypotenuse. And I know you might be thinking, why don't we just measure the length of these sides? I mean, you can see from this triangle and this triangle, okay, they're fairly similar size, and so the lengths clearly, one of these must be incorrect at least, if not both, okay? We just need to remember that usually these drawings will not be to scale. They want us to do some kind of maths that's not just measurement, okay? We're using Pythagoras Theorem here to find out what that missing side is. Okay, so we use Pythagoras to find the missing side of a right-angled triangle. Okay, so let's use what we've done before. We're going to call this side A, this side B. It doesn't matter with the other two sides which is A and which is B, because all we're going to do is square them and add them together. Okay, and X can be our C side. That's the only one that has to be the same every time. Okay, so let's put it into our formula. So A squared plus B squared equals C squared. So A squared, okay, 6 squared plus B squared, which is 8, equals X squared. Okay, so let's try and solve this left-hand side of the equation first. 6 squared, 36. Okay, if you're not sure, you can use a calculator. Okay, 8 squared is 64. Okay, and that gives us X squared. So one more step on this side, 36 plus 64. Well, 6 plus 4 is 10. 6 plus 3 in our tens column is 9, plus that 10 we had left over. So 100 is X squared. Does that mean that this side is 100 then? Just be careful. This side is X. We've found X squared. So we just need to square root both sides. So that gives us X equals 10. Okay, and that actually is just our solution there. So our solution is X equals 10. So that longest side of our triangle has a length of 10 units. So we've learned a little bit about Pythagoras Theorem. We've done one example now. I'm going to give you the choice. You can either try 1, 2 or 3 of these questions, pause the video here, have a go and then come back, see how you got on, or you can stick with me for now and stop at whatever point you feel comfortable to try some yourself. If you don't want to try any by yourself and you just want me to go through these 3 while you follow, that's absolutely fine as well. Okay, we're going to start with question 1 then. Okay, and these questions have got slightly different challenges each time, so it's worth looking at all 3 of them. So question 1, we can see again, right angle triangle. Okay, we've got a side of 8, a side of 15, and a missing side, which is C this time. So where we used X before, we just called it C this time. Okay, so let's use our formula here. A squared plus B squared equals C squared, Pythagoras' theorem. Okay, and we're going to try to work out this missing side C. Okay, so we may as well use our colours. Okay, A would be 8. We could have said 15 if we wanted to. Okay, A and B, as I said, don't need to be in a particular order. As long as C is this longest side, this hypotenuse, okay, then we should be okay. So 8 squared plus 15 squared equals C squared. Okay, now this is where you may need your calculator. Okay, you may not, it doesn't matter. Okay, 8 squared gives us 64. Okay, 15 squared, probably a tricky one. Okay, if you want to do it without a calculator, think about 10 times 15, and then half of that, 5 times 15, add them together. So it should give us 225. Okay, equals C squared. And like we did in our example, I'm just going to add those together. So 4 plus 5 gives us 9. 2 plus 6, sorry, is 8. And then we've just got the 2 in the hundreds column. Okay, so 289 equals C squared. Now you probably could need a calculator for this. Okay, we already know that 15 squared is 225. Okay, but let's just see on our calculator, just to be sure. So the square root of 289, okay, gives us 17. So like we said before, we need to square root both sides because we want c, not c squared. Okay, we do need to find out c squared, but our final answer is going to be what c is. Okay, and c is equal to 17. Okay, and again, make your answer nice and clear. Okay, so question 1 is solved there. Question 2, we've got a little bit of extra information. Find the value of c to 2 decimal places. Okay, so again, we've got 2 shorter sides. We should notice those are the 2 shorter sides. Okay, and the hypotenuse is this long side here. So we're going to use our formula again. Let's put our numbers in. So 8 squared plus 11 squared equals c squared. Okay, and again, 8 and 11 could have been either way around. We're just going to add them together once we've squared them. Okay, so let's think about 8 squared again. We've got it up here. We had it in the example. 64. 11 squared we might know. Okay, 121 equals c squared. Okay, so just like the last question and the example, every time we do these, we're just going to do the same thing. Add up these 2 numbers. So 1 plus 4 gives us 5 in our units. 6 plus 2 is an 8. And just the 1 in our hundredths. Okay, and again, we need to square root both sides. So we know we're going to end up with just c. Let's have a look. The square root of 185. Okay, it gives us 13.60147 and so on. Okay, look at our question then. So sometimes we do get an integer, a whole number, as our answer. Sometimes we won't get a whole number as our answer. Now we could have just left that as a square root of 185. If we knew about surds, we might be able to simplify that as well. However, it's asked for 2 decimal places, so let's make it nice and clear next to it. C equals 13.601 in our 3rd decimal place. We know that rounds down. So our solution is 13.60 there. Okay. Our final question then. Now, you'll notice this time it's asked for the value of b, not the value of c. Okay, and I've maybe thrown a bit of a spanner in the works as well because we've been using A as our red pen, and actually this time B is our red pen. As I said though, it doesn't matter which way round A and B go. So we can just say this time that 10 is A. Okay, plus B squared equals C, but this time we know C is 12, so 12 squared. Okay, now this is all good, but how are we going to work out B here? Because we've not got the B on its own on one side of the equation. Okay, so we need to do a bit of rearranging here. So actually, how can we just get this B on its own? So we've got B plus 10 squared, so why don't we remove that 10 squared, so subtract it from both sides. Okay, because we've got positive 10 squared, if we take away 10 squared, it gives us 0 on that side. We just need to do the same to this side as well. Okay, so b squared equals 12 squared minus 10 squared. Okay, now we can just work out which of these squares are. So 144 is 12 squared. Okay, take away 10 squared, which is 100. Okay, so we can say b squared equals 144 minus 100, just 44. And then just like we did before, we're going to square root both sides. So b is going to equal the square root of 44. Okay. I know it's not going to give us a whole number. So it gives us 6.6332495881 and so on. Okay, again, it asks for the value of b to 2 decimal places. Okay, so we can say b equals 6.6. We've got a 3, then another 3, so it's going to stay as a 3 there, isn't it? Okay, so b equals 6.63. Okay, so there are times when we're going to have to rearrange our equation. Okay, so either a or b might be the one we're finding, the shorter side. Okay, we just need to move the side that we do know over to the other side, so it's essentially going to be c squared minus a squared equals b squared now, or it could be c squared minus b squared equals a squared, but we should know how to do that rearranging. Okay, and it doesn't matter if we do it here or if we work out the value of these first and then subtract it. Okay, either way, we're going to get to that correct answer.